Do you feel the vibes?
So we covered, trigonometry, and we learned about trig ratios, and we learned how to evaluate trig ratios of an angle. This chapter is on trigonometric identities. A trigonometric identity is basically two equivalent things or two quantities that are equal that are set equal to each other. All right, those are trig identities. So for example, these are some of the trig identities we're going to start with. You already know these concepts, you just didn't know that we formally call them a trigonometric identity, right? So for example, the first ones we're going to look at are the reciprocal identities. So you already know that cosecant is the reciprocal of sine, right? 1 over sine. You know that secant is 1 over cosine. Cotangent is 1 over tangent. You already know these. This is nothing new. We now have a name for these. They're called the reciprocal identities. There are many, many, many identities. All right. The next one we're going to come across is the quotient identity. The quotient, there are two of them. Basically, sine over cosine is equal to tangent. Okay. And then because cotangent is the reciprocal, then it's cosine over sine. Okay, that's cotangent. So let's take a look at that actually. So suppose you have a triangle like this. This is theta, and these sides are 3, 4, and 5, right? Okay, so sine of theta is 3 over 5. Cosine of theta is 4 over 5. And just by looking at the triangle, what is the tangent of theta? 3 over 4. Now, the identity says you can also do sine of theta divided by cosine of theta, which would be 3 over 5, divided by 4 over 5, right? So that's 3 over 5 times 5 over 4. Oh, cancel the wrong things. Right? The 5's cancel, and I get 3 over 4, which is the tangent of theta, right? Okay? So sine theta over cosine theta always gives us tangent of theta. Now, in a situation like this, it's silly to do what I did in the red to find the tangent, right? But if you had, some things missing, or, like a different situation, then this could be used, right? Also. So those are what trig identities are. Now, okay, let's talk about the VIP of all trigonometric identities. That is the Pythagorean identity, right? Okay, so we know the Pythagorean theorem. It's a squared plus b squared equals c squared. So take a look over here. We have this lovely triangle on the unit circle. Once you do unit circles, no triangle exists outside the unit circle, right? Everything just gets scrunched down into a unit circle. So we've got this lovely little thing. So if this was x and if this was y, then the Pythagorean identity would say, okay, x squared plus y squared equals 1 squared, right? Nothing new. But we also know that if this is the coordinate of a point on the unit circle, right? And we have an angle that intercepts that point, then this distance, the x, is the cosine of that angle, and this is the sine of that angle, correct? So what we called x before is really the cosine, and what we called y before is really the sine. So you could say x squared plus y squared equals 1. I might say cosine theta squared plus sine theta squared equals 1. Do you see how these are the same thing? It's just x squared plus y squared equals 1. Now, Who says we have to have it in that order? Why can't I do sine theta squared plus cosine theta squared? We know those are interchangeable. So here we are. Sine theta squared plus cosine theta squared equals 1. Now, this is a good way, this is a correct way of writing sine of theta squared with the parentheses. However, a more efficient way to write that same thing in math is if you put the square over here. Sine squared theta plus cosine squared theta, and that is equal to 1. And this right here, like I said, is the VIP of trigonometric identities. This is called the Pythagorean identity. If you tell anybody who knows math, Pythagorean identity, everybody knows what this is. It's just like we know what the Pythagorean theorem is. Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. I mean, everybody knows it, right? I mean, all the cool people anyway, right? So, like, it's embarrassing at some point if you're like, you're a math person and you don't know this. I mean, that won't even happen, okay? So, let me talk a little bit about notation. So, sine of theta squared, I said, can be written as sine squared theta. So, what you're doing here is you're squaring the sine. So for example here, what was sine of theta? 3/5. What's the square of that? 9/25, correct? That's what you're doing. Now, if you mess up and if you write this as sine of theta squared like this is a whole other situation. There, you're squaring the angle. It's like the angle here was, 47 degrees, and now you made it like sine of, whatever 47 squared is. Those are two very different things, okay? So, very, very important where that exponent goes. Okay, so now, here is the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. That's everybody's favorite Pythagorean identity. Now, suppose you take that and, just for fun, because you can, you're like, hey, I'm going to divide everything in that identity by the same thing. And you're like, okay, what should I divide it by? Okay, so why don't we divide everything here by cosine squared? Because why not? Okay, so I'm going to divide this by cosine squared theta, divide by cosine squared theta, divide by cosine squared theta. This middle here cancels. What do you get instead? A 1. Now, what's sine divided by cosine? What did we say that was? Tangent. Now, sine squared divided by cosine squared is tangent squared, right? The exponents just carry. So this will just be tangent squared theta plus 1 is equal to, and what's 1 over cosine? Secant. So 1 over cosine squared will be secant squared theta. And just like that, look, that's the second Pythagorean identity. Okay? Yeah. So you don't want to miss this stuff. Okay, so now, suppose I took my original Pythagorean identity. What did we divide by last time? Cosine squared. This time, let's divide by sine squared. We're on a roll here. So this gives you a 1. What's cosine over sine? Cotangent. So this will be cotangent squared theta. And we know that 1 over sine is cosecant. So when you square everything, this is cosecant squared theta. So that is the other one, okay? So this is, the main Pythagorean identity, but it's got friends, right? Now, this one in red, you have to memorize it. That's not even a discussion, okay? Now, you should also know these two, but if you forget, right, because, the one is in a different place than the original, and you're like, okay, this tangent, what goes with what? You can just derive it. Just divide one thing by the sine, divide one thing by the cosine, okay? Okay. All right? You can always derive it. Okay. So, who was asking me about this yesterday? I think it was in a different class. Okay, we've got some other identities. The negative angles and the cofunction identities. Okay, let's talk about negative angle identities. So let's talk about sine of negative theta. Okay, what does that mean? Okay, let's see. Where is pi over 6? Right here. Now, what's sine of pi over 6? This number, correct? Okay, because it's the y value, right? So how do you get to that point? You go up 1/2. Now, so that's pi over 6. Where is the negative of that angle? Negative pi over 6. Oh, that's right there. What's the sine of that? It's the same distance, but down this time, so it's a negative, right? So when I change the angle from positive to negative, or vice versa, because sine is the y value, it gets reflected upwards and the sign will switch. So here, sine of that angle will be positive. Here, it'll be negative. Okay? Okay? Now, it works for any of the angles. Take a look at this angle. The negative of that will be here. Okay? So, 1 has a value of negative root 2 over 2. What's the negative of that? Positive root 2 over 2. Okay? So, when you have sine of negative theta, the negative basically comes out, the sign will be negative. Now let's talk about cosine. Look at the pi over 6. Where is the cosine? It's this distance. Now, when I take, instead of positive pi over 6, if I take negative pi over 6, has the cosine changed at all? It's the same. It's literally the same segment. So when the angle goes from negative to positive and vice versa, the cosine will stay constant because it's literally that same segment and it does not change. Okay, so that's why here cosine of negative theta is just the same. It's cosine of theta. It does not change when the angle becomes the negative of itself. Tangent is sine over cosine, so obviously if one becomes negative, the other one will too. So tangent changes sign. Okay? All right. How are we doing? Okay. Is that mine? It's not mine, is it? Okay. Somewhere over there. Okay. Here's a question for you. After that, color by numbers situation. What's the sine of 30 degrees? 1/2. Okay. Do you remember from geometry complementary angles? What would be the complement of 30 degrees? 60 degrees. So now, we did the sine before. What's the cosine of 60 degrees? 1/2. Okay, so that's a thing. If these angles are complements of each other, now, you know how sine and cosine, like one is the co of the other, this is where it comes in. Secant and cosecant, tangent and cotangent, these are called cofunction identities. And the cofunctions are the same for complementary angles. Okay, Ms. Malikin, what the heck are you talking about? Well, exactly this. So for example, suppose I had sine of, give me a number, 40. What will this be the same as? It'll be the same as sine cosine of the complement. What's the complement? 50. Okay, so if I had secant of, 10, what will be the same as? What will that be the same as? Cosecant of 80, right? So if I had the tangent of 20, what will that be the same as? cotangent of 60. Okay? So how do I get these other angles? I do 90 minus this, 90 minus this, 90 minus this. In radian, what would that be? Pi over 2 minus the angle, correct? So if I have an angle, okay, so suppose my angle is, I don't know, suppose I have like sine of, I don't know, pi over 9. Who knows what that is? I don't know what that is. What will that be the same as? It'll be the same as cosine of the complementary angle. That's 90 minus, right? What's 90? Pi over 2 minus. You see that? So those are the complementary the cofunction identities. Sine of pi over 2 minus the angle is cosine, right? Cofunction identities, all right? Cosine and tangent are the same, okay? All right. Whew, all this, let's now apply some. Okay, so given the following questions, for the following questions, I say to use trigonometric identities only, no triangles. In the last chapter, we learned how to find the answer to this using triangles. Fine. You can still do this using triangles, but not in this chapter, because the purpose of this chapter, the objective is for you to learn trigonometric identities. So for these, we're only going to use trigonometric identities. So let's take a look at these. For these, always determine what you have and what you need. So what am I given here? We're given that cosine of theta is some number, so this is what I'm given. Find the exact value of sine of theta. This is what we need to find. Okay? Now, I'm given one other piece of information, that theta is between 90 and 180. That means what quadrant is my angle in? 2. Okay, good. So I have cosine, I need sine. I go to my list of identities. Which one combines sine and cosine? Nothing here. We just need sine and cosine, no other third party. This red one, the Pythagorean identity, is the one that combines sine and cosine. So that's what we're going to use. So we say sine squared theta plus cosine squared theta is equal to 1. I'm given cosine theta, correct? So sine squared theta plus, what was cosine of theta? Negative a half, but it's squared, equal to 1. Now I need to find this. Sine squared theta, oops. I love these. Plus 1 over 4 is equal to 1. What do I do now? Subtract 1 over 4. Sine squared theta is equal to 3 over 4. Okay, now how do I get sine if I have sine squared? What do I do? Take a square root. But now, when you take a square root of both sides, you get plus or minus root 3 over 4 is the square root of 3 over 2, correct? Now, we can't have one answer. We could only have one answer. But we're in luck because we know what quadrant we're in. We're in the second quadrant. In that quadrant, is sine positive or negative? Positive. So I gotta go for sine of theta is positive root 3 over 2. Okay, so let me just write that here. In quadrant 2, sine of theta is positive. I mean, we just know that it's, well, we knew that. We knew it was between 90 and 180.
But like, we know the exact value.
No, we don't know the exact value of the angle. Well, I mean, you can find it in that, right. Well, you could have found that out from here.
Oh.
Right? But I just gave you 1/2 right now for a special angle, but it will never be like that. It will be like, I don't know, 3 over 7 or something. And by hand, you can't find the angle. Okay, so again, we could have done this very quickly using triangles. Fine. But again, what do I always say? Is it ever about the final answer? It's about the process. It's about the process. Okay, so here we go. This one, we can't figure out what the angle is. But We're given sine of theta is negative 2 over 7. We are in which quadrant? 3. And we need to find secant. So go to your identities. Which one, the first, second, or the third, are we going to use? So we have a choice here, right? We need secant. We have sine, we need secant. Okay, here is secant, but I don't have tangent. But wait, this one has sine and cosine. So if I use this to find cosine, could I then find the secant from it? If I have the, yeah, so let's do that. Okay, so, all right, so sine squared theta plus cosine squared theta is equal to 1. All right, negative 2 over 7 squared plus cosine squared theta is equal to 1. Square this, positive 4 over 49 plus cosine squared theta equals 1. Now I need to subtract 4 over 49. Cosine squared theta is equal to 45 over 49. I take a square root. Cosine is plus or minus root 45 over 49. Okay, but root 45 can simplify, right? Because it's 3 root 5. Now, is it going to be positive or negative in this quadrant? Negative, because cosine is negative in quadrant 3 over 7. So negative in this quadrant. So cosine of theta is equal to negative root 45 over 7, which is negative 3 root 5 over 7. Okay, that's great, but I need secant. Secant of theta is negative 7 over 3 root 5. Rationalize that denominator. So secant of theta is negative 7 root 5 over what? 15. All right?
I have the negative 2 in the sign.
Huh?
I have the negative 2 in the sign.
It got squared to 4.
Oh, right.
4 over 49.
No, wait,
Yeah.
I mean when you didn't sign up for cosine.
I didn't get tangent. I used this one. I didn't need tangent.
Oh, you didn't do that.
No, because I couldn't, because I didn't have cosine. Okay, so that's one thing we can do with these. Now, another thing is trig identities can be used in simplifying expressions. Now, here is where sometimes, you know, okay, so here's the thing. In the real world, you will never be handed an expression and say, here, simplify this. That doesn't work like that. Usually these things will be in like step number 4 of like, I don't know, 20 steps of a problem. And then you have to simplify it in order to suit your needs, right? So today we're just doing that one thing. It is a little bit out of context when we first do it. So when we say simplified, you're going to be told, let's say, simplify so that it can be written in terms of one trigonometric function. So like just a sine or just a secant or just, you know, cotangent. All right? Okay, so that's what we're going to do. Now, how do we do these? The biggest trick I can tell you is rewrite in terms of sine of theta and cosine of theta. All right, so you see how I have cosecant, cotangent? Switch all of them into either sines or just cosines. So here we go. Sine of theta is already sine of theta. Now, What's cosecant? Cosecant is 1 over sine of theta. Yeah? What's cotangent? Cosine over sine. Do you see what I did? I really haven't done much math. I just rewrote them in terms of their like sines and cosines. Now, this sine and this sine here cancel out. So in that entire numerator, I am left with a 1 over cosine theta sine theta. So what is that? 1 over a fraction is its reciprocal, sine theta over cosine theta. In one trigonometric function, that is tangent theta. And that's where I'm done. Yeah? Okay. Oh, there are supposed to be parentheses here, right? Yeah. Okay. So let's do the same thing here. Sine of theta. First, okay, the cosecant is 1 over sine minus sine of theta. Remember to never ever drop the theta or the x, right? You have to have it there. Okay, now I distribute. So sine of theta times that fraction, what does that give me? A 1 minus sine of theta times sine of theta, sine squared theta. Now, here we go. Let's examine what we have. I have a trig function squared, and then that's being added or subtracted from a 1, right? So I have a trig function squared in conjunction with plus 1, minus 1, and so on. Whenever you have that, that is code for, in another world, but I like the way you think. This is code for Pythagorean identity. All right? So, do we have a Pythag? Okay, so the first one has that. Okay, so let's use that one. Okay. So, the identity says sine squared theta plus cosine squared theta equals 1. Now, these are not rigid structures. These are meant to move around, okay? What if I subtract sine squared from both sides? What does that give me? That gives me cosine squared theta is equal to 1 minus sine squared theta, right? Isn't that the same? Isn't that literally the same? 1 minus sine squared theta. Oh my God, that whole thing is just cosine squared theta. And just like that, I reduce this to one trig function. Okay, right? Yes. I mean, honestly, this. I am having so much fun. Okay, so I was actually, I wrote these notes from scratch, right? So yesterday I was actually like, I solved all of them, like just to make sure I didn't have any typos. And oh my gosh, it was so much fun, right? Right? Because when I solve the same problems year after year, I'm like, okay, I've done this. But like, these are fresh, like brand new problems, never before touched. Okay, let's do this next one. Did you say I've never taught this chapter? Is that what you said? Well, okay, I have been teaching this chapter for over 2 decades. Okay, all right, this is how gossip starts. Okay. Huh?
You never got like this far.
It's so we, with all the holidays and stuff, we rarely in Algebra 2 cover chapter 13. It happened in the year 1617. That happened. I covered it then in Algebra 2 honors. But 2016, 17. 2000, the year 2016, 17. But also, this is big in pre-calculus. It is big in pre-calculus. This is the second chapter we cover in pre-calc honors. And so this is the point. This is what we're doing. Okay, so let's take a look here.
It's not hard.
Okay, So, hard or not, this is Algebra 2 honors. This is what we do. You'll be fine. Secant. What am I going to write secant as? What about tangent? Sine over cosine of theta. Do you see how the main fraction bar, right? I make it just a little bit longer than the other fractions just so I can like identify what ends where and so on. Okay, now look at what we have here. 1 minus cosine squared theta. Okay, I have a sine squared theta. What do you all think? Yeah, sine squared theta. Because if I take that Pythagorean identity and I, maneuver it, this will be sine squared theta. Okay. All right, so here, let's deal with this fraction here. I have 1 over cosine theta times cosine theta over sine theta times sine squared theta. Okay. Now, don't go cancel happy. Just reduce what you can reduce, right? Cosine with cosine. Now, what about the sines? 1 sine cancels with 1 sine. So what do I have left? Oh my God. Look at this. Would you ever have imagined all this is just equal to sine of theta? Like, how cool is this? Right? Right? We're going to be positive. Okay. No, we're going to be positive. Okay, so here we go. Let's do this next one. Okay. Too many things. Let's just write them in terms of sines and cosines. So tangent squared will be sine squared over cosine squared. Cosecant squared will be 1 over what? Sine theta squared, right? Sine squared theta minus 1. Okay, fine. And then I have, what is this? Secant squared, 1 over cosine squared theta. Okay, so let's see. Let's deal with this pesky numerator here. Too many things. But look, sine squared and sine squared will cancel out. Okay, what do I have now? I have 1 over cosine squared theta minus 1 over this. Okay, now this doesn't look very pretty. But what's 1 over cosine squared? Secant squared theta. This is secant squared theta minus 1 over this. Hang on, but you can't cancel those, right? Even if it were. Okay, now let's go back. Got secant squared theta minus 1. What do you think? Look at this one. If I subtract 1, I have tangent squared theta is secant squared theta minus 1. Right? So what is this equal to? Tangent squared theta. Right? Just this. Okay, so now over 1 over cosine squared theta. So now, what's tangent? Sine squared theta cosine squared theta times cosine squared theta. Okay, so let's see what we did. I did the red divided by the purple, but divided by the purple means times 1 over the purple. Yeah? Yes? You all with me? Red. Red is now sine over cosine. Tangent is sine squared over cosine squared. So red, 1 over purple. And so times the reciprocal. This cancels this. What do I have left? Sine squared theta. And if that doesn't deserve a happy face, I don't know what does. Okay.
Press